Good afternoon, this is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, today we will discuss the reliability of Trivariate econometric modeling. In the last lectures, we have discussed the entire structure of Trivariate econometric modeling, where the system consists of three variables y, x1 and x2. That means, one dependent variables and two independent variables. So, the way we have last class we have received the estimated model, just we highlight here. So, we start with y equal to alpha beta 0 plus beta 1 x 1 plus beta 2 x 2 and plus error terms. So, through which we have received the estimated models y head equal to beta 0 heads plus beta 1 head x 1 plus beta 2 head x 2. Okay. So, now the next the moment you will get the estimated model, the next step is to go for the reliability testing. So, for the reliability is concerned, like bivariate econometric modeling, we have to go for again two different test structures, that is reliability with respect to parameters and reliability with respect to overall fitness of the models. So, now the moment you will get the estimated models, so the testing or you can say reliability is all about, we can say two parts. So, first is to know the significance of parameters, okay, and to know the overall fitness of the model, overall fitness of the models. Okay. So, this is how we have to go for this assignment. So, now let us start with the estimated parameter side first, then we will go for overall fitness of the models later. Okay. So, then what we have to do? So, far as the overall fitness of the model is concerned, so we have to so far as the reliability of parameters are concerned, so we have to receive all such information, so that we can get to know whether this x 1 is a significant one or x 2 is a significant one. So, that means we have to take care of this beta 1 head and beta 2 heads. So, let me highlight how easy all about this particular structure. So, that means in the first case it is the reliability of parameters. Okay. Reliability of parameters. So, we have to report the results like this: the estimated parameters, okay. Then estimated parameters, then variance, then standard error, then t statistics and corresponding probability. So, estimated parameters we have to receive beta 0 head, okay, then beta 1 head, then beta 2 head, okay, corresponding variance of beta 0 head, variance of beta 1 head, variance of beta 2 heads. Okay. So, then beta 0 head by okay, no, this is square root of variance of beta 0 head. Okay. So, then square root of variance of beta 1 head, okay, then variance of beta 2 heads. Okay. So, this is, so we will call it a t here, then we will call it a p here, all right. So, now t is nothing but beta 0 head by standard error of beta 0 head, then beta 1 head by standard error of beta 1 head, then beta 2 head by standard error of beta 2 heads. Okay. So, then corresponding probability we have to check it. Okay. So, what is this actually beta 0 heads? So, beta 0 head basically beta 0 head is equal to y bar minus beta 1 head x 1 bar minus beta 2 head x 2 bars. Okay. So, that means we first get to know what is beta 1 head and what is beta 2 head. So, once we have beta 1 head and beta 2 head, then we can able to calculate beta 0 head. So, the initial step is to know what is beta 1 head and beta 2 heads, then everything will be coming automatically. So, now, so beta 1 head is equal to beta 1 head equal to summation x 1 y summation x 2 squares minus summation x 2 y into summation x 1 x 2, okay, divided by summation x 1 squares into summation x 2 squares minus summation x 1 x 2 whole squares. Okay. So, now similarly beta 2 head is equal to summation x 2 y into summation x 1 summation x 1 square, right, then minus summation x 1 y into summation x 1 x 2. Okay. So, divided by summation x 1 squares into summation x 2 squares minus summation x 1 x 2 whole squares. Okay. So, this is how the estimated parameters has to be obtained. Okay. So, now after getting all these beta 1 and beta 2 heads, so if you put to here, beta 2 head here and beta 1 head here, then you get to know the beta 0 heads. So, now we like to know how is the structure of, you can say, variance of beta 0 head and variance of beta 1 head and variance of beta 2 heads. So, after getting beta 0 head, beta 1 head, then beta 2 heads. So, next step is to know what is the variance, and once you get the variance, then you can able to calculate the standard error and followed by t statistics, then you have to go for the level of significance. So, the first means the next step is just to calculate the variance of beta 1 head, variance of beta 2 head and also variance of beta 0 head. So, that means here variance of beta 0 head, equal to sigma square u, okay, 1 by n plus x 1 bar squares summation x 2 squares plus x 2 bar squares into summation x 1 squares minus 2 x 1 bar x 2 bar summation x 1 x 2, okay, summation x 1 x 2, like this summation x 1 and x 2 divided by summation x 1 square into summation x 2 squares minus summation x 1 x 2 whole square. This is what the, you can say, beta 0 head variance. So, similarly, variance of beta 1 head is equal to sigma square u summation x 2 squares divided by summation x 1 squares into summation x 2 squares minus summation x 1 x 2 whole squares. Okay. So, this is variance of beta 1 head. Okay. Similarly, variance of beta 2 head is equal to sigma square u summation x 1 squares divided by summation x 1 squares into summation x 2 squares minus summation x 1 x 2 whole squares. Okay. Whole squares, yes, whole squares. So, now, so we have beta 0 head, estimated of beta 0 head, beta 1 head and beta 2 head, then followed by variance of beta 0 head, variance of beta 1 head and variance of beta 2 heads. So, now to get the exact value of, you can say, variance of beta 1 head and beta 2 head, beta 0 head, beta 1 head and beta 2 head. So, we like to know the value of sigma square u first. So, the moment you will get the sigma square u, then everything can be possible here. So, what is sigma square u? So, sigma square u is equal to summation e square by n minus k. Obviously, in this trivariate it will equal to n minus 3. So, now sigma square equal to summation e square by n minus 3. So, now we like to know what is summation e square. Summation e square is error sum square. So, which is nothing but summation y squares minus summation y head squares. Okay. So, summation y square equal to summation y square equal to summation y minus y bar whole squares. Similar, but summation y head square is equal to beta 1 head summation y x 1 plus beta 2 head summation y x 2. Okay. So, this is how summation y head squares we have to receives. Okay. So, now everything is with everything is with respect to this calculation. So, now we have summation x 1 square, summation x 2 square, summation x 1 x 2, sigma square u, summation e square, then summation y square, summation y head square. So, now we have to just integrate properly to get to know whether the parameters are statistically significant or not. Okay. So, now what you have to do? So, the moment you will get this variance of beta 0 head, beta 1 head and beta 2 heads, then you can just take a square root, you will get standard error of beta 0 head, standard error of beta 1 head, standard error of beta 2 head, then followed by t equal to beta 0 head by standard error of beta 0 head, standard error of beta 1 head by standard error of beta 1 head, then beta 2 head by standard error of beta 2 heads. So, this is how you have to proceed. So, now what is our agenda here? So, our agenda is to get to know what is this particular component and whether this particular component is statistically significant. These are the formulas or structures through which we have to examine the level of significance, or you can say test the reliability of estimated parameters for the trivariate econometric modeling. Okay, to justify the entire themes, we have to take a numerical problems, then we can able to interpret everything, because these are all theoretical way we are just bringing the structures, but actual thing will be possible when you have the data in your hand. So, in this particular setup, so we have taken a problem here consist of 9 observations and there are 3 variables here y, x 1 and x 2. So, by the time beings we should not discuss anything about the name of y, name of x 1 and name of x 2. In fact, when we will go for interpretation, then that times this the variable naming is very much important, because by the way of variables information we can interpret the particular things. It is after reliability test, and when we will go for policy implication, or you can say detailed discussion about this estimated models. So, in the time being, so keeping in mind these 3 variables, we like to know how is the shape and structure of reliability of estimated parameters. Okay. So, now we need to know first what is estimated model. So, the moment you will get the estimated model, then you have to follow the sequence. So, what is the setup here? So, altogether we have to set like this: y head equal to beta 0 head plus beta 1 head x 1 plus beta 2 head x 2. Okay. Then obviously, this is variance of beta 0 head, then variance of beta 1 head, then variance of beta 2 heads. Okay. So, followed by t of beta 0 head. So, I am skipping the standard error component. So, t beta 1 head, then t beta 2 heads. Okay. Then followed by probability level of significance, probability level of significance, probability level of significance. So, now what is y head here? So, now we need to first calculate beta 1 head, beta 2 head. So, beta 1 head is equal to, what is beta 1 head here? Now, summation x 1 y into summation x 2 squares, okay, minus summation x 2 y into summation x 1 x 2 divided by summation x 1 square into summation x 2 squares minus summation x 1 x 2 whole squares. Okay. This is how the entire structure is all about the beta 1 heads. So, now in this particular information, so we have to calculate all these things, but you remember one thing here, these particular items are in deviation format. Okay. So, what you have to do for this time being, so we have to go for in a particular structure. So, what is this particular structures? So, here the theme is for this particular problem. So, let me first we will highlight all these detailed steps through which we will get the estimated model. So, now this is the step 1. Step 1, as usual, we like to present the descriptive statistics. Okay. So, this descriptive statistics will give you the briefing about this particular structures. Okay. So, the step 1 process is to know the descriptive statistics. Okay. So, descriptive statistics means the structure will be y x1 then x2. Okay. So, this is, so we need to know the maximum value, minimum value, okay, then a mean, okay, then standard deviations, okay, then some skewness kurtosis is also required. So, in the meantime we are summarizing with respect to maximum value, minimum value, mean and standard deviation, because these are all essential for this to check the reliability of the estimated model. So, now for this particular problem, so the maximum of y is equal to 4477, then this is 113 and this is 5.74, then minimum is 2620, then this is 80, then 4.79. okay. So, mean is coming 3553.5, then it is 103, then this is 5.175, corresponding to standard deviation is 638, then this is 11 and this is 0.38. okay, 0.38. So, this is how the entire descriptive statistic for this particular problem. So, now what do you do? So, next step is you have to give again the summary of the entire variables. So, what is the summary of entire variables? So, now for this particular problem, so we need to have summation x1, summation x2, then summation y, okay, then summation x1 squares, then summation x2 squares, then summation x1 x2, then summation x1 y, okay, then summation x2 y, x2 y. okay, this much of information we need to know. okay. What is summation x1 here? Summation x1 is summation x1 is here 1 2 3 6. okay. So, 1 2 3 6, then summation x2 is 62.1, then summation y is 426, then 42. okay. So, this is how the entire structure, and in fact I have not added all other columns here. I am just giving the summary of this particular result. So, sum x1 square, sum x1 square is equal to 128,646, then sum x2 square equal to 322.95. okay. Summation x1 and x2 is equal to 6423.9, then summation x1y is equal to 4461715, then summation x2y is equal to 222952.8. okay. So, this is the entire summary of this particular problems, that is with respect to y, x1 and x2. So, what you have to do first? So, you need to quickly calculate summation y, summation x1, summation x2, summation y square, summation x1 square, summation x2 square, summation x1 x2, summation x1 y, summation x2 y. Then we have to move to second step. So, these are the entire information we need to, you can say we need to proceed for the significance of the parameters. So, then we have to move to the step 3. What is the step 3 process? Now, the step 3 process is to transport all these concepts, all these components what we have received from the step 2, that in a deviation format. Okay. So, that means what do we need? We need summation x1 squares, then summation x2 squares, okay, then summation y squares, okay, then summation x1 x2, then summation x1 y, then summation x2 y. okay. I think this much is enough. okay. Three such deviation format is requires. okay. So, here x1 small x1 is a deviation format, that is nothing but capital X1 minus x1 bar. okay. So, that is in original figures. So, now Similarly, we have to calculate summation x2 square, summation y square, summation x1 x2, summation x1 x2 means sum of x1 minus x1 bar into x2 into minus x2 bars. Okay. Similarly, summation x1 y means summation x1 minus x1 bar into y minus y bars. Okay. So, this is all about in a deviation format. So, we directly transfer entire item into deviation format, so that we can quickly have the t calculated value. Okay. So, now we like to know what is summation x1 square. Summation x1 square equal to 33165, then summation y square equal to 42358,756, then summation x1 y equal to 1167621, then summation x1 and x2 equal to 1626.7, then summation x2 y equal to 57447.7. Okay. So, these are the items we have to receive from in a deviation format. Okay. So, the moment you will get the in a deviation format, then your step is very smooth now. So, we can proceed very quickly. Okay. So, what do you do now? So, we need to know what is the in the step 4, we like to know the beta 0 head value, then beta 1 head value, then beta 2 head value. Okay. So, what is beta 1 head here? So, beta 1 head is equal to here summation x1 y into summation x2 squares minus summation x2 y into summation x1 x2. Okay. So, divide by that summation x1 square into summation x2 square minus summation x1 x2 whole square. So, that is called as a determinant A. Let us assume that this is a determinant A. So, similarly, this is nothing but summation x2 y into summation x1 square minus summation x1 y into summation x1 x2 divided by mod A. Okay. Divided by mod A. Okay. So, now if once you get this particular value, then you put in beta 0 head. Okay. By the calculations, what we have received. So, we have received the items, let us say we can directly move to step 4. So, we have to write like this: y head equal to beta 0 head, which is nothing but minus 4334.13, then plus 34.875, then this is obviously x1 plus 830.04 x2. Okay. So, that means this is beta 0 head, this is beta 1 head, and this is beta 2 head. So, I have here omitted number of steps because of lack of time. The way is because we have already reported here all these figures. So, you just put all these figures here, then you calculate. If you apply in scientific calculator, you can say Excel sheet, you can directly get this, but this is how you have to proceed, and ultimately you will get this particular figure. So, this is for the this you will get later. First you will calculate this one, then you have to calculate this ones, then put this and this in equation 1. So, that is what is known as y bar minus beta 1 head x 1 bars minus beta 2 head x 2 bars. Okay. If it is equation 1, then you put this ones, then you will get beta 0 head. So, that means the estimated value of beta 0 head is 4334.13, then beta 1 head is 34.875, and beta 2 head is 830.04. So, okay. So, now we like to know what is the variance of this particular structures. Okay. So, what is the variance of this particular structures? So, now what you have to do? So, we have to move to step 5. Okay. Step you have to move to step 5. So, now once you have beta 0 head, beta 1 head and beta 2 head. So, then you have to calculate the variance of beta 0 head. So, variance of beta 0 head is equal to you have to find out, and variance of beta 1 head you have to also find out, and variance of beta 2 head also you have to find out. Okay. So, now I am not writing directly. So, ultimately the way we will move to variance of beta 0 head, or from beta 1 head to variance of beta 1 head, and variance beta 2 head to variance of beta 2 head, then of course, we have to move again for standard error of beta 0 head, then we have to again move for standard error of beta 1 head, then again we have to move for standard error of beta 2 head. Okay. So, this is how you have to proceed. Ultimately, again we have to move for t of beta 0 head, then again we have to move for t of beta 1 head, again we have to move for t beta 2 heads. So, of course, we need to know this and this, and this, then t beta 0 head equal to beta 0 head by standard error of beta 0 head. So, similarly t beta 1 head and similarly t beta 2 head. So, now we like to know what is this value, what is this value, and what is this value. So, this particular value, if we will calculate by by putting all these values in that particular equation, then standard error of beta 0 head we have to receive here 546.79. By the way, I am omitting few steps here, because if we will go each steps one by one, then it will take lots of time. So, you just remember this particular formula, and I have already calculated the deviation values. So, you put all these values in that particular equation, then you will be able to get variance of beta 0 head, variance of beta 1 head, and variance of beta 2 head. So, now I am not directly calculating all these figures. So, here I am just reporting, so that we can quickly proceed for the significance level, because ultimately our aim is to know whether this particular item is statistically significant or not. Okay. So, but we need to have calculated value first, and we need to have a tabulated value. So, calculated value you have to calculate by this process. So, the basic idea is just to know briefly descriptive natures, and actually this descriptive nature, in fact, in the initial it will not help, it will help in the later stage when we will go for interpretation. Okay. So, by the way, as per this stepwise process, so we have to little bit know about the descriptive, because it can give you the variance variation between all sample points. Okay. So, then we have to go for step 1. So, where you will represent the summary of all these variables, then you transport this summary of variables into deviation format in step 3. Then now, in the step 4, you just quickly calculate the parameters beta 0 head, beta 1 head, and beta 2 head. Then in the next step 5, we have to calculate the variance of beta 0 head, variance of beta 1 and variance of beta 2 head. So, the formulas I have already presented here. So, now what I have to do, I am just already I have already figure out this particular problem. So, all these information which is readily available here, it can be transferred into the deviation format. Just you add 3 columns here, y x 1, y x 2, then x 1 and x 2, x 1 square, x 2 square, y square. Okay. So, this column 6 columns once you add, then obviously you make it sum total, then the entire the summary of this particular variables in capital format you will receive immediately. So, by the way, in the by mathematical formula you have to transfer into the deviation format, then through the deviation format, then everything will be in a sequence. Okay. So, now here by this process, so we have received a standard error of beta 0 head equal to 546.79, standard error of beta 1 head equal to 4.509, and standard error of beta 2 head is nothing but 130.93. By the way, even if you can also skip the standard error of beta 0 head, standard error of beta 1 head, and standard error of beta 2, you can directly get the t beta 0 head, t beta 1 head, t beta 2 heads. But before that, once you have standard error, then you have to integrate with the hypothesis. Okay, that is a null hypothesis and alternative hypothesis. Null hypothesis that beta 0 head equal to 0, beta 1 head equal to 0, beta 2 head equal to 0. So, that means we start with that the coefficients are not at all significant, they are not contributing anything. Then ultimately, we have to set the alternative hypothesis corresponding to beta 0 head, beta 1 head, and beta 2 heads. So, here in the case of alternative hypothesis for beta 0 head is equal to means beta 0 head not equal to 0, and for beta 1 head. So, beta 1 head not equal to 0, then for beta 2 head alternative hypothesis beta 2 not equal to 0. So, that means in the null hypothesis we assume that beta 0 head equal to 0, beta 1 head equal to 0 and beta 2 head equal to 0. Then alternative hypothesis we will set beta 1 head not equal to 0, beta 2 head not equal to 0 and beta 3 head not equal to 0. The moment we will put not equal to 0 alternative hypothesis, that means it will give signal in two ways. That means we can go for either one tail test or we can go for two tail test. Okay. So, that is speciality how you are setting the null hypothesis and alternative hypothesis. By the way, so we need to by the help of null hypothesis setting and the standard error of all these parameters, then we can able to calculate the t statistics. Okay. So, now if we will apply by this particular process, then t of beta 0 head you will get here 6.34 no sorry t of beta 0 head equal to, it is coming negative, that is minus 7.926. Okay. Then t of beta 1 is coming here 7.735 and t of beta 2 head 2b head is coming coming here 6.340. Okay. So, that means we will just bring it here. So, 2 beta 0 t beta 0 head equal to minus 7.926, then t of beta 1 head is equal to 7.735 and t of beta 2 head equal to 6.340. So, this is also very high, this is also very high and this is all very high. So, now what you have to do? In fact, the high may be create some distance. The high does not mean that the variable will be statistically significant, because the significance of this particular item depends upon the tabulated value, and tabulated value also depends upon the level of sample size. Okay. So, now sample size and the involvement of variables are the two indicators through which we can get the significance level. So, now very quickly we can assess the tabulated value from the tables. So, that is with respect to this degrees of freedom. So, where n equal to 9 and k represents 3. Okay. So, now corresponding to this n and k and one tailed and two tailed test at 1% level, 5% level or 10% level. So, you start with 1% first. If it is okay, then you proceed. If it is not, then you have to go for 5%. If not, then you have to go for 10%. So, let us assume that at 1% levels. So, it is actually say 2.96 and this is called 2.96 and this is called 2.96. That means, in this particular problem x 1 is statistically significant, x 2 is statistically significant. That means, the beta 1 coefficient is statistically significant, beta 2 coefficient is statistically significant. That means, both x 1 and x 2 are significant factors through which y can be changed, or you can say y significantly influenced by x 1 impact and x 2 impact. This is how the model can be interpreted. So, that means, in this particular models, so x 1 x 2 are highly significant factors through which y will change in this particular setup. So, now this is one part of the problem. Okay. So far as reliability of the parameters is concerned. So, similarly, we quickly have the structure of the ANOVA. Okay. So, that is an analysis of variance. So, that will bring the overall fitness of this particular system. So, the way we will means we have already proceeded the calculation of beta 0 head to t of beta 1 beta 0 head and beta 1 head to t of beta 1 head and beta 2 head to t of beta 2 head. Then we have followed the statistical procedure through which we get to know the a statistical significance of the parameters. Similarly, ANOVA is also in that particular track. Okay. In fact, we have discussed details the ANOVA analysis of variance in the bivariate setup. So, now same thing it can be represented here, just an addition of another variables. Let me explain what is this particular structure of ANOVA. Okay. So, now here ANOVA. So, now second part of this particular reliability is ANOVA. Okay. So, ANOVA means analysis of variance, which we have already discussed. So, ANOVA structure is like this. So, we like to know the sources of variations. In fact, the structure of ANOVA is in fact structure of the estimated parameters also more or less same. So, in comparison with the bivariate setup, in the bivariate setup there is only two variables y x 1 say and in the case of trivariate it is y x1 and x2, and again for multivariate it will depends upon how many independent variable you are integrating in the system. So, after this lecture we can quickly proceed to multivariate analysis and we can discuss detail about that issue. So, in the meantime, the way we have finalized the bivariate setup, the same thing we have here also in the trivariate setup. So, more or less in the case of ANOVA, the table is very unique. Okay, there is no such change, but so far as the value of that particular component, constant component like error sum square, you can say residual sum square, there is a change, because this formula is slightly different from this particular bivariate setup. Because why? Because there is a involvement of third variable in this particular system. So, obviously, what first of all we bring this ANOVA tables, then we quickly highlight what is the setup here in the trivariate setup. So, now this is sources of variations. Okay. So, then next is the sum squares, then mean sum squares. Okay. So, then degrees of freedom, then F statistic and probability level of significance, okay, P. Okay. So, sources of variations is you can say ESS, then RSS, then TSS, okay, so which we have already received. Okay. So, what is this sum square here? Sum square is here for ESS it is summation y hat square, this is summation E squares and this is summation y squares. Okay. So, corresponding to this one, so your mean sum square equal to summation y hat square divided by k minus 1, then this is summation E square by n minus k, and this is summation y square by n minus 1. Okay, k cancel, it is the sum of these two. Okay. So, now this is k minus 1 degrees of freedom, this is n minus k degrees of freedom, this is n minus 1 degrees of freedom. Okay. So, now we come to the F statistic subsequently. So, you see here the entire structure is more or less same like bivariate issue. So, only difference is here is that, so the k value only. Okay. In the case of bivariate setup, k equal to 2, obviously n according to your problem setup. So, but in mathematically in the case of bivariate k equal to 2, but n depending upon your sample size. In the case of trivariate this k becomes 3, that is the only difference in this particular structures. Of course, there is a change in between the inside picture of this particular sum squares. Okay. So, what is this difference? Let us see here. So, now as usual summation y square will be remain same, summation y square equal to summation y squares minus n y bar squares. So, this is how we have to receive summation y minus y by r square, this is in deviation format. You remember one thing, when we move from bivariate to trivariate or trivariate to multivariate. So, that means when we move from k equal to 2 to k equal to 3, k equal to 4, k equal to 5, k equal to n. So, in all the cases whatever size of your model, so your summation y square is always same. Okay. It will not change at all, only change is on the right hand side. Okay. So, that is how the summation y square in that is in the left side, which is considered as a dependent variable, is remain fixed. Okay. Only change is with respect to independent variables, that is what the trivariate and multivariate all about. Okay. So, now summation y square case is almost all same for bivariate, trivariate and multivariate, but there is a change with respect to ESS, with respect to RSS only. Okay. So, that means in the case of TSS, so it is same for bivariate models, trivariate model and multivariate model. Okay. So, it is not at all different. Okay. So, it is more or less same. Okay. So, now we will see what is ESS here. So, ESS is nothing but summation y hat square. So, summation y hat square. So, summation y hat square can be written like this, summation y hat square is ESS. So, which is nothing but written like beta 1 hat summation y x 1 plus beta 2 hat summation y x 2. Okay. So, in the case of bivariate models, we write summation y hat square equal to beta 1 hat square summation x square. Okay. Beta 1 hat square summation x square. So, beta 1 hat square equal to summation x1 y summation x square. So, here also same thing. So, what we have do, we put it in a different particular format. Okay. So, you see here, so beta 1 head square summation x square means summation if you put instead of x, if you put x 1, then it is nothing but summation x 1 y divided by summation x 1 square. So, it is summation x 1 square. So, summation x 1 square, this is also square because beta 1 square here. So, this is summation x 1 square. So, summation x 1 square, summation x 1 square cancel. So, it is nothing but summation x 1 y whole square by summation you can say x 1 square. This is what is called as a summation y head square, alright. So, now similarly it can be written like beta 1 head summation y x 1. Okay. So, the way we will redesign, so it will be only this particular format. Okay. So, now since there is another involvement, another variable involvement, so there is another term here involved in the numerator side. Okay. So, in the below the summation y square is there, it is remain constant, that is total sum square. So, this is y head square. So, obviously, so summation e square equal to summation y square minus summation y head square. So, what is the procedure here? The procedure is we first have summation, obviously summation y square in the very beginning we have. So, we have to calculate summation y head square because beta 1 head is already with us, beta 2 head is already with us, summation y x 1 we have already calculated, summation y x 2 also we have already calculated. So, now we have to just process it, then ultimately we will get summation y head square. So, the moment you will get summation y head square and you have already summation y square, small y square. So, you just make a subtractions, then you will get the summation e square. Okay. So, once you have this ones, this one and this one, so then you can able to get the mean sum squares, okay, with respect to error sum square, residual sum square and total sum square, provided it has to be integrated with the proper degrees of freedom. Okay. So, now ultimately in this ANOVA we have two different objectives, okay, altogether. First objective is to know what is r square value, okay, and second objective is whether this r square value is statistically significant. For that we need to have f value. So, that means ANOVA is meant to bring the overall fitness of the model, which is judged by r square, that is coefficient of determination, and on the other side f, which can justify the significance of this overall fitness of the model, that is r square. In fact, here the adjusted r square which we have discussed in the bivariate has lots of meaningful interpretation in the case of trivariate, because adjusted r square means r square is adjusted with respect to degrees of freedom. In the case of bivariate, the degrees of freedom cannot change, okay, in my it is a n minus 2, it is same, but the degrees of freedom can change here because we have introduced third variables, okay, that means k is 3 here. So, obviously, adjusted r square will get affected, means in frankly in reality adjusted r square has a meaningful interpretation if we will integrate both n and k. So, that means it depends, it adjusted with respect to sample size as well as the involvement of variables in the systems. So, n represents sample size and k represents the involvement of variables in the system. So, if we integrate together, then adjusted r square has to be calculated. Let me highlight what is all these issues. So, the issue is here. So, we r square, we have to calculate r square, that is coefficient of determination. Coefficient determination in means the physical interpretation is that the percentage influence of independent variable to dependent variable. So, percentage influence means it is the ratio between exponent sum square by total sum squares. Okay. So, now it is the ratio between exponent sum square by total sum square. So, means if you will go by mathematical formulation, then it will be coming here beta 1 head summation y x 1 plus beta 2 head summation y x 2. Okay. So, divide by TSS, that is summation y square. Okay. This is how you have to receive this r square component. So, corresponding to r square, we will get adjusted r square. Adjusted r square is nothing but 1 minus r square into n minus 1 by n minus k. Okay. So, that means this particular structure is also in the case of bivariate setup, but bivariate setup this k is equal to 2, here we need k equal to 3. Okay. So, accordingly we have to get the adjusted R square. The moment the moment you will add one after another variables in the system, then your R square value will be increase frequently. The reason is that because total sum it is the ratio between explained sum square by total sum square, but total sum square in every case is remains same, whether it is bivariate or trivariate or multivariate, but in the upper side it is adding frequently, because when we go for bivariate setup, then the item is this much only. Okay. So, when we will go for trivariate, then it is this much only, means altogether. So, now when we will go for addition of fourth variable, then it will add another item here, beta 3 head summation y x 3. Okay. So, if you add another variable, then beta 4 head summation y x 4. So, like this you have to proceed subsequently. So, that means if you follow that particular path, every time the numerator value will start increasing, but in the same times y square summation y square that is in the below side, it is remain constant, whether it is bivariate or whether it is trivariate or whether it is a multivariate case. So, in every case, so lower portions is always constant. Okay. So, once you add one after another variable, so R square will be substantially high and high. So, that is how when we will go for trivariate modeling or you can say multivariate modeling, it is better to have adjusted R squares or better to use adjusted R square rather you can say R square. And when we will go for purely multivariate models, that time adjusted R square is the much reliable component to justify the overall fitness of the model, because it adjusts with the degrees of freedom, that is with respect to number of variables involvement and number of you can say sample size involvement. Okay. So, now corresponding to R squares. So, this is how we have to bring the overall percentage influence of the independent variable to dependent variable. So, now it has to be tested. So, how do we test for that? So, testing follows F statistics. F is the ratio between ESS by RSS. Okay. ESS by RSS, of course, it is nothing but R square by k minus 1 divided by 1 minus R square into n minus k. Okay. This is how this is k minus 1, this is n minus k. So, just we have borrowed from this particular setup here. So, okay. So, this is ESS and this is RSS. So, the ratio between this particular two will give you the F statistic. Okay. This will give you the F statistics. So, now once you have F statistics, then you have to proceed here for this significance level. So, now as usual we have discussed in the T case, F case is also same. So, with respect to you can say the variables involvement and sample size, we have to see the F tables and get the tabulated value. So, this is calculated value. So, accordingly we have to get the tabulated value, then we have to make a comparison. By the way, when we will process all these information, because we have already received the ESS value, we have already received the TSS value, that means we can able to now get the R square value. Okay. So, R square by the process is equal to 0.982. In fact, I am omitting here these steps. So, I am directly writing the results, means if you use all these information in this particular formula, then ultimately you will get R square equal to 0.982. So, similarly, adjusted R square we will receive here 0.965. So, that means there is a drastic difference between R square and adjusted R square. In fact, between the two, this is more reliable than this one, because it is not adjusted with degrees of freedom, rather it is adjusted with degrees of freedom. That is why adjusted R square is 0.965. So, suppose you are very much interested for overall means judging the significance of the overall fitness of the model. So, again in this case you can also apply F statistic, and if you apply adjusted R square, then F statistic corresponding it is adjusted R square by k minus 1, then provided 1 minus adjusted R square by n minus k. Okay. So, this is how it can be adjusted with degrees of freedom. So, now by the process we have to receive the F value. So, now once you use this R square value, then f can be calculated as a 123.993. So, this is how the calculated value of f. So, this is calculated value of f, calculated value of f, and we have already received the tabulated value. So, now we have to make a comparison. So, accordingly we have to give a conclusion, but if you know, you remember one thing, very this there is always thumb rules. So, whether it is the significance of the parameter or significance of the overall fitness of the model, if the t value by a look it is coming high, then no point to go for checking the tabulated value. Generally those who are very experts or great statistician or econometrician, so they do not like they can guess whether this particular variable can significant or not. So, here in this particular set, why I am saying, because f is coming very high. So, 123.93 with respect to this sample size. So, that means you just close your eye and you can say that it is highly significant. It is highly significant at 1% levels. Okay. So, that means that is the best, okay, for so far as the significance is concerned. So, now in fact in the bivariate models what we have received, both the parameters beta 0 had and beta 1 had significant, and in this case also same things we have received, means both R square is significant and beta 0 had, beta 1 had and beta 2 had significant. In fact, over the long run when we will go for multivariate, then supporting component, that is beta 0 had, has a very less impact. We like to always look what is the supporting factor to all variables, that is with respect to beta 1, beta 2 here, all right. So, now since here the major findings is that, so beta 1 head is highly significant, beta 2 head is highly significant, and in the same times R square is also highly significant. So, that means this conclusion is that the model is reliable one. So, it can be used for forecasting or policy use, but if by any chance if beta 1 head, beta 2 head are highly significant and other case R square is not highly significant, or vice versa, like beta 1 head, beta 2 head is not significant and R square is highly significant, then the model reliability has a weakness. It is not like that you have to look only one part of the problem. So, both the parts has to be taken care together. So, then it will give you a bright picture of this modeling. So, whether it is a bivariate setup or multivariate setup, every time we have to go through particular process, that is to check the reliability of the parameters and to check the overall fitness of the model. So, if both are going in a right direction, then your model can be best fitted and can be used for forecasting and policy use. With this we have finished this this particular trivariate econometric modeling. In the next class we will discuss the multivariate modeling. So, that is more interesting, more classics. So, we will discuss in detail in the next class. Thank you very much. Have a nice day.